So the sequence of numbers from the tabular patterns in the Beatbox exhibit is, of course, the famous Fibonacci sequence. Now, it's pretty unusual for a mathematical sequence to be famous outside of the maths community, but the Fibonacci sequence has made it big. It's quite famous. The first few numbers of the sequence are 1, 1, 2, 3, 5, 8, and then it continues forever. What defines the Fibonacci sequence is that at any point in the sequence, you get the next number by adding the previous two numbers in the sequence together. So, for example, the first two numbers are 1 and 1, add them together, you get 2, add together 1 and 2, you get 3, which is the next number along, and so on. So now we move to the maths in a minute part of our podcast, and I'm going to challenge Rachel to tell us as much as she can about the Fibonacci sequence in 1 minute. Ready? 1, 2, go.
Back in the 12th century, Leonardo Fibonacci was thinking about some really highly fictionalized rabbits. You start with a pair of baby rabbits, one male, one female, and they mate after 1 month, producing another pair of rabbits at the end of the second month. And then they'd keep on producing a pair of rabbits, a male and a female, at the end of every month from then on. So at the end of the first month, they mate, but you still only have one pair. At the end of the second month, they'd produce a new pair for the first time. So now you have two pairs. At the end of the third month, the original female would produce a new pair. So now you have three pairs. And at the end of the fourth month, the baby rabbits produced 2 months ago produced their first pair, while the original rabbits produce another pair. So now you have 5 pairs. Fibonacci wanted to know how many pairs of rabbits will there be in 1 year. Well, the total number of pairs this month is the number of adult pairs plus the number of baby pairs. And the number of adult pairs is the total number of pairs last month, including adults and babies. And the number of baby pairs this month is the number of adult pairs from 2 months ago, as it takes them at least 2 months to be old enough to produce babies. So the total number of pairs this month is the number of pairs last month plus the number of pairs the month before. We get the sequence 1 pair, 2 pairs, 3 pairs, 5 pairs, and so on, now known as the Fibonacci sequence, where each number is the sum of the previous two numbers in the sequence. And knowing the pattern of the sequence, you can work out that after 12 months there will be 144 pairs of rabbits.
Wow, that was great. That was almost all in 1 minute. Now, real rabbits obviously don't breed as Fibonacci described in his maths problem, but his sequence still appears frequently in nature, and it seems to capture some aspect of growth. You can find it, for example, in the turns of some natural spirals. You can find it in plants, for example, sunflowers, and even in the family tree of bees. The sequence is also closely related to a famous number called the golden ratio. You can find out more about Fibonacci on our website at plus.maths.org and search for Fibonacci.